Welcome everyone. Today we are discussing the phenomena shown by the waves. And the first phenomena, basically there are so many phenomena, but in GCSE we will be studying only two, which is reflection and refraction. So today we are starting reflection. So let me see what exactly a reflection is. See, the first thing is it's a misconception that reflection can be shown only by the light ray. It's about the waves. So every wave shows the reflection. Now, reflection is bouncing back in the same medium. There is a word medium. It's nothing. We are talking about a particular form. Basically, if I say solid, liquid, gas, so they are mediums in which a ray, a wave is traveling. If a wave travels in solid, then it's called a medium, a more denser medium, because the particles are quite closer in solids. Whereas if the same wave is traveling now in liquid, so the medium has changed because solid and liquids are different forms. So in terms of the waves reflection, we use this word medium. So medium is nothing in which the wave is traveling. Now coming back to the reflection. Reflection is bouncing back off a wave in the same medium. This is a surface. And a wave falls on it. It is like that and it bounced back in the same medium. Let me assume that this wave was traveling in air. And this is, suppose, a solid surface. So it just bounced back in the same medium, and that is called reflection. It was traveling in air, and now after falling on the solid, it's again back in the same air in which it was traveling. So simple, how can I say reflection? Reflection is, so if I label each of this one, I can say this ray is called incident ray. This one is called incident ray. And this ray, because it has bounced back, has been reflected, called as reflected ray. We will be studying each and every term while I discuss the laws of reflection. Laws of reflection, it states that if a light wave is falling on a surface and bounced back, then the angle of reflection will be equals to angle of incidence. Now let me see what is this exactly. As I told you, the light ray that will be incident on the surface is called incident ray, and light ray that is being reflected is called reflected ray. An imaginary line which is perpendicular to the surface, this is perpendicular and it will pass through just the vertex of it. This is normal. The angle between this normal and the incident ray is called angle of incidence, which I am representing with theta I. Whereas the angle between the normal ray and the reflected ray is called theta R. This is called reflected ray. Now, let me see each and every term of it. This is called surface. This is a surface. Our first is incident ray. A light or a ray of any wave. So because here we are studying the light specifically, so let me say a light ray which is incident on the surface is called incident ray. Second is reflected ray. A light ray third is the normal, and it's an imaginary line that is perpendicular to the surface. You can clearly see it's making a 90 degree. It's important. So it makes 90 degrees. So we can say it's an imaginary because we are doing this one. These are actually happening, like light rays falling, bouncing back, but there is no normal actually. But for our convenience, for the calculations, for understanding, we have assumed that there is a line perpendicular to the surface, and that's why we call it as an imaginary one. Next is angle of incidence, which I'm representing with theta I. Angle between the normal and incident ray is called angle of incidence, which I'm representing with theta I. So if you see this diagram, you can clearly see theta I, that is angle of incidence, is the angle between the normal and the incident ray. Similarly for theta R, which is angle of reflection, I can say this is the angle between the normal and reflected ray. So I can write down the definition here as angle of reflection is the angle between reflected ray and normal. Now let me see the laws of reflection. So the most important law of reflection that we have in our syllabus is the angle of incidence is always equals to angle of reflection. So here if we see the diagram, you can say theta I, theta R, they both are always equal, and that is called the law of reflection. So law of reflection states that angle of incidence is always equals to angle of reflection. That means theta I is equals to theta R. Now, let me see what is an image. When you see yourself in a mirror, you see your image. When you see yourself in a water, you see your image. So it's basically the reflection. And how exactly these images are formed? When the reflected rays meet at one point. So how can I define image? I can say that the image is formed when reflected or refracted, because image can be formed when the rays are reflected or when the rays are refracted. In both the cases the images are formed. So they meet at one point or appears to meet at one point. Now this is a little bit confusing. Okay, after reflection they are meeting, but what does this meaning appears to meet? Let me see, and on the basis of that the images are categorized as real image and the virtual image. So let me see how exactly the images are formed, and then we'll see what are real and virtual image. This is a surface. Now the light falls on the surface, and then after reflection it's like this, another wave, and now meeting. You can clearly see after reflection they both are meeting. This was incident ray, this was incident ray. Now after reflection they meet at a point, so definitely at that point the image will form. Now if I change this case, suppose the light rays are falling like this, reflection happens and reflection happens. Now if I say, is there any possibility that they can meet these two waves? This is a reflected image. Incident, reflected, incident, reflected. So reflected ray has to meet to form an image. If I extend them, they keep on moving away from each other. They are diverging. So they cannot meet. Then will the image form? In that case, still the image will form. Now the sentence will be justified. Appears to meet. What will happen if you trace them backwards? They will meet at one point. So this seems like they are meeting somewhere at behind the mirror. So that's the meaning, that they appears to meet, and that categorize the image as real image and virtual image. So let me see what are real image and what are virtual image. When reflected rays meet at one point, there the image is formed. Which image? Real image. So see, this is a surface, light incident, then light gets reflected, then another incident and gets reflected. What's happening here? They are meeting at one point, this. So you can clearly see reflected rays are meeting at one point, and we can say that here the real image will be formed. Now there are few characteristics of real images. So if we see its characteristics, first thing is you can clearly see after reflection, if this is a mirror, then so we can say the image is formed in front of the mirror. When rays meet at one point, that means they are converging, then this real image is formed. So we can say light rays are meeting at one point. They can be taken on screen. Screen, that means if you want to see how it looks, that is taken on a screen. so they can be taken on it. Now let me see virtual image. As I told you, when the reflected rays cannot meet at one point, but they appears to, actually they are diverging in nature, but they meet at somewhere behind the mirror, then the type of image is called virtual image. Now let me see how its diagram looks like. This is a surface, this is a light ray, and this is the reflection. This is another light ray and it gets reflected. Now there's no chance that these two can meet because they are in diverging nature. If we extend them behind the mirror, they will meet at one point. And here image will be formed. That is your virtual image. So if we see the characteristics of these, then the first thing is image is formed by diverging rays. Second is, if you see this one, here image was formed in front of a mirror, but here it's not forming in front of mirror, instead it's forming behind the mirror. The kind of image that you can see in the plain mirror, like the mirrors that are in your bathroom or in your home that you use, that is a plain mirror. So image formed is a virtual image. It cannot be taken on screen, just like the real image you can take, but virtually cannot. So these are basically the types of images. Now let me see the types of reflection. So basically there are two types of reflection. First is called the specular reflection and second is called the diffuse reflection. So let me see the types of reflection.
Now let me see the specular reflection. It's a type of reflection that we get from a very smooth and a shiny surface. So in this reflection, the incident light is reflected into a single outgoing direction, and you will get a very defined and a clear image. See what happens. Suppose this is a surface. Now light falls on this surface and then it gets reflected. Then another ray and it gets reflected, and another ray, it gets reflected. So what's happening is, after reflection they are meeting at one point, and clearly, because as I just described you, image is something that is formed when reflected rays meet at one point or appears to meet at one point. So here they are actually meeting at one point. So to form a very clear image, all the reflected rays coming from an object should meet at one point so that they can form a complete image. So convergence is important in that case, and here, because they all are moving into a single outgoing direction, they are meeting at what point and a very defined image will be formed. So how can we describe specular reflection? So it's a reflection formed by polished, smooth and a very shiny surface. Because what will happen in this shiny surface, the absorption rate is very less, and if absorption rate is very less, so the maximum light will be reflected. To be honest, it's not possible that it will be formed naturally. Like if I'm talking about the perfect specular reflection, you cannot get. You can get in a man-made space, but naturally it's not that possible. But still you can say the still waters are an example of natural's ability, so nature's ability to produce this type of reflection. If I talk about the image, what kind of image is formed? A very defined and a clear image is formed. A diffuse reflection is a kind of reflection that is formed by a rough surface. What happens, as I told you, like in a specular reflection, the absorption is quite less. But in diffuse reflection, because there are so many surface irregularities, the complete reflection is not possible. Sometimes more absorption takes place, and that's the result that most of the light cannot escape, or you can say cannot be reflected, and at the same times they are not in the same direction. So that what happens is, like, each ray will be moving at a different direction at a different angle, and all the reflected rays are not able to meet at one point, and this is the reason a very blurry image or sometimes no image will be formed. So you can say a diffuse reflection is a reflection formed by a rough and a very unpolished surface. If we see this one, suppose it's a surface, this is a light ray, maybe reflection will occur like this. Next ray reflection will occur like this. Next ray reflection will occur like this. So you can clearly see they are not meeting at one point. Maybe this will meet here, these two rays are able to meet at one point, but other than other rays are not able to meet at a point. So what's happening is the all reflected rays are not able to meet at a point, and in this case a very blurry image will be formed, and sometimes no image is formed at all. Now there is a misconception. People think because a very defined image is forming, they are in a like moving parallel and in a defined direction. So in specular reflection, the laws of reflection are applicable. The law of reflection is applicable, whereas diffuse, which is a haphazard, the law of reflection is not applicable. This is a big misconception. Laws of reflection are applicable. This is a star thing. The law of reflection doesn't care about what kind of reflection is it. It's always applicable as long as there is a reflection there.
Now let me do some questions on reflection. Question 1 says, calculate the angle of reflection if angle of incidence is 30 degrees. According to the law of reflection, angle of incidence is always equals to angle of reflection. That means theta I is equals to theta R. And if theta I is equals to 30, that means theta R will also be 30. Now let's see the next one. See, the question says, if the angle between the reflected ray and the normal is 40 degrees, then calculate angle of incidence and angle of reflection. We know perpendicular line is what? Normal. This is incident ray, this is reflected ray. Angle between normal and incident ray is theta I, whereas angle between normal and reflected ray is theta R. Here it's given the angle between the reflected ray and normal. That means reflected ray and normal, which means theta R is given here, which is 40 degrees. So if theta R is equals to 40 degrees, that means angle of incidence will also be equals to 40 degrees. So for A, theta I is equals to 40 degrees and theta R is also equals to 40 degrees. And what's given? Theta R is given, which is 40 degrees. Let me see the next question. If angle between the surface and incident ray is 65 degrees, find the angle of reflection. That means same, I'll draw surface, normal, this is incident ray, this is reflected ray, this is angle of incidence, this is angle of reflection. Now let me see what's given. They have given that angle between the surface and incident ray. This is incident ray and surface is this one, the flat one. This angle is 65. And as we know that normal is perpendicular, which means this whole is 90 degree. So theta is definitely 90 minus 65. So what we can say, angle between surface and normal is 90 degrees. Whereas angle between surface and incident ray is 65. So angle of incidence theta I will be 90 minus 65, which is 25 degrees. And we know theta is equals to theta R, so ultimately theta is also equals to 25 degrees. So basically that's it for today. We'll be continuing the next topic in waves in our next lecture. You can access the free revision notes, questions and Akzsi app. Link is in the description box. If you need to book one-on-one live online classes as well as batch classes for GCSE. See, this is an academy and we have tutors for every subject from year 1 to year 13. So if you want to book classes, just email us at exaiacademy@gmail.com. And if you need batch classes for GCSEs, the same thing. To book your demo, either you can go to our website, which is exaiacademy.in, or you can email us at exaiacademy@gmail.com. The prices are very affordable, and in that too little price, you're going to get a best experience. So that's it for today. Thank you and have a great day.